Before taking the derivatives of trig functions, we're going to need to evaluate two special trig limits. The first is the limit of sine x over x as x goes to 0. So consider this diagram. In green, we have a circular sector. So from O to B is a radius, and from O to A is also a radius, and the radius equals 1. So we know that the sine of theta, of course, equals BC over hypotenuse. So in other words, sine of theta equals the length of BC. We know that the arc AB, since it's an angle of theta, and that angle theta is in radians, then that arc is going to have an arc length of theta because the radius is 1. And it's pretty easy to see that line segment BC is less than arc AB. And so what this means is that sine theta is less than theta, or another way to say it is that we know that sine theta over theta is less than 1. Okay, there's piece number 1 that we're going to need. Second of all, we're going to look at AD. Well, of course, if we look at this larger triangle and we take the tangent of the angle, the opposite is AD, and the adjacent, which is OA, is 1. So AD equals the tangent of theta. And it's pretty easy to see that that tangent of theta is going to be larger. AD is going to be greater than or equal to the arc AB. And again, equal to only when we shrink the angle down all the way to 0. And so what this means is that theta is going to be less than or equal to tan theta. Theta is less than or equal to sine theta over cosine theta, and a little bit of reconfiguring of this, we get that cosine theta is less than or equal to sine theta over theta. Well, that's the other piece that we need. Now what we can do is create the combined inequality and put sine theta over theta between cosine and 1. Now we're going to take the limit as theta goes to 0, and notice that at 0, cosine goes to 1, and of course 1 goes to 1. So by the squeeze theorem, if the two things bounding it go to the same limit, that means that the thing in the middle must go to the same limit, and therefore the limit as x goes to 0 of sine x over x equals 1. And that is an enormously important result. You can verify that numerically on a calculator. That is an enormously important result which we'll need when we take the derivatives of trig functions.